Okay, we're going to take a model of the hydraulic power plant now and illustrate how we obtain the state space form using CAMPG and using the equations that were used for the state space form. Also, how do you actually produce a SIMULINK model in block diagram form? So in here we have this model that is of a power plant, and it has two tanks. Those C's are the tanks. Has some inertials on the pipes and a discharge here, and the SC's are the hydrostatic pressures sources. So we are going to go to the interface here of to MATLAB to generate our model in here, and we're going to get let CAMPG and MATLAB speak with each other, do an interface in there, and get this model onto the system here, onto the screen. So just remember that this bone graph model will relate to these files that CAMPG just produced. So the file for the state space form is the CAMPG SYM file. So in here we are going to use this to produce the state space form. So in here we have, if we just run the file directly, the computer is telling us that we have these inputs in here, and this is the state space vector. One thing that is important in here is to understand what variables are your state variables here. In order to do that, it would be a good idea to have the CAMPG, to have the bone graph on the side to do this. So let's just do that so that you can see now we have taken the bone graph model from the that we had, and we put it into this nodes in here that we're building to relate to our system in here. But you can see in here what the computer is telling you. It has SE1, SE2, SE3 as inputs. Those are this. And then you have SF8, which is over here, which is a gate that we are going to close to illustrate how this power plant, shadow of the power plant works. But in here, you have Q11. It means Q11 is the volume in the first tank. Q14 is the volume on the second tank. And then you have P sub 9 and P12. Those are the momentums of the water inside the pipes. Those are your state variables. So if you need to specify the height on the tanks, then the variable to look at is Q11 and Q14, because those are the volumes. If you divide that by the area, you get the height. So that's one thing I wanted to point out. But in here, if we go on, the computer produce the A matrix, as you can see in there, in symbolic form, and it produced the B matrix in symbolic form. At this point, the computer doesn't know what outputs you want. This file produced from CAMPG to MATLAB needs to be changed to specify the outputs. Because if you try here, it gives you this generalized notation that it says this is going to be a symbolic file in here, but I don't know what it is. So what you need to do is we need to go back to the I just got out of there so that when we run it again, we do it with the correct outputs. So in this file here, if the outputs are the pressures in the tanks, what variables in the bone graph should we choose? That would be, it would make sense to be E11, which would be the pressure, right? And E14, right? So if that's the case, I go in here and I use the find option in here, and I say find me E14 or E11 first. So when I say this is E11, CAMPG produce outputs for every single effort and flow in the system. But if they are commented out, they are not active. So we are going to make them active and say, you know, I'm interested in E11. This is going to be my first output, and that output is going to correspond to the first row of the C and the D matrix. And then I go and I say, look, this is E14, which is my second output. And in here, I am going to go ahead and say this is output number 2. And that output is going to be my second row of the C and the D matrix. So once you do that, you could just run this again, and the computer would actually produce the whole state space matrices, as you're going to see in just a moment. So there's your A matrix, there's the B matrix, and now the C and the D matrix are also produced. So that's how we get the whole state space form generated using CAMPG. Now, having said this, another objective of what we were doing right now is given the state space equations that CAMPG generated in first order form. These equations are here. See, there's that one, there's this, and there's this, and there's that. There's 4 equations for the for the derivatives and 2 equations for the outputs. So we need to illustrate now how do we go about getting those 4 equations into the block diagram directly into SIMULINK. So you could do it drawing first by hand and then transfer to SIMULINK. But today we're going to venture ourselves into doing it directly from these equations into SIMULINK. And so what I would like to do is to get a summary of these equations next to the bone graft model, so that we can handle those very efficiently. Okay, so now we have extracted those equations that generated the matrices. As you could see, the 4 differential equations at the top, the state space equations in first order form with Q11, DQ11, DQ14, DP9, DP12. That means DP12 dt, DQ9 dt, and so on. And then you have the output equations for the 2 pressures, E11 and E14, on the bottom. So our task right now is to use these equations and produce a block diagram, which we are going to do it directly in SIMULINK at this time. So what we need to do in here is we could develop a strategy here to make sure that we fit all on the screen. We could start with the largest long equations and then go to the smaller equations. That's one way of doing it. The other way would be, it really doesn't matter where you start. You just create 4 differential equations that produce 4 state variables by doing the integration, and then see the signals that you need to use to build up the last one, which would be the longer equations. My feeling is that you could do it either way. So just to be in order, I'll just start it from the top and go all the way to the bottom, and let's see what happens. Okay, so in here I am going to need each equation is a summation point. So I am going to go to the commonly used equations. I need to have my first equation visible because that's the one I'm working on. And then in here you have this, first of all, doesn't have any sources, but it has a summation point. And where is the summation point? You know, right here. And also, because it has two terms of these gains, I need two of those, like that. I'm gonna also need one integration here, and also I'm gonna need one scoping here. See? So we have this. So in here, let's just do this a little bigger here. Is gonna have two of these, and then of course this we need to invert this so that they will add over here, and one is a plus sign and the other is a minus sign. So this is going to be with the plus sign, and the other one would be with the minus sign. In here we will join these two and this two. Let's make sure that we give some labels to this. This is, you know, this is DQ11 DT. DQ11 DT, like this. This is that derivative. And then once it's integrated, of course, this is Q11. Yeah? And in here, this term is 1 over I sub 9 P sub 9. And the other one is 1 over I sub 12 P sub 12. So I'm just going to put it here, 1 over I sub 9 right there. What happened? Did I invalid setting? Why is that? Let's try again. And this 1 over I sub 9. This should be okay. Okay, we made a couple of corrections here, and we are about to join the I9 and I12 in here. We have a plus and the other one is a minus, so we need to change this to be a minus in here, like that. And then this is going to be the minus would be this other one would be this. So this is the one that we need to, this is going to be I12 in this case. So this is our first equation with what we have, the DQ11 DT in here. These connections obviously depend on P9 and P12, which we do not have yet. So we need to work it out in such a way that we have those. Let's just move the whole thing to the left so that, oops, here. There we go. So we make some space. So my next objective is to do the DQ14 DT, and it has the same format as the other equation, except this one has a source. I would just do a Control V and C to get the same element in here. We also need an integrator here. We need this also. We could bring it up from here. It's just that it would be a little easier that we have already there's blocks in here. This has only one. We just need to get the summation point has one minus for the source and one plus. So I'm going to put the minus first and the plus second. So this would be minus and then plus, yeah? And now we need this for the source in here, which is going to be SF8. I'm just putting here SF8 like this. And that one, that's this part. And in here, this is the derivative in here that we're doing. This is dq14 dt. And then this one right here is going to be dq14. Q14. Very good. And then this would go to be p sub 12 over I sub 12. So we'll go 1 over I sub 12, and yeah. So that's it. So we have built the second equation. Now we need to build the third equation. So we're going to go and hide this small browser, so it gives us some space in here to build this third equation. This dq9 dt has 1, 2, 3, 4 terms. So in here we'll again we do need we need a summation point. Also, well, yeah, we need an integrator, and then we also need a scope. And then how many of the gains do we need? This one is necessary. We have two sources. We have two of these gains. I would just for convenience bring those blocks, although we need to change the names, make sure that that happens, otherwise we'll be making some mistakes. So in here we have this is just to make sure we are on TP9 dt. Okay, and this one is p sub 9 as well, right? We have two sources in here, so we're gonna have that one, and then we're gonna go two of these, and we have, so in total two sources with plus and the others with minus. So we are gonna have two pluses right here and two minuses, right? Oh, like, okay. So if that's the case, we need to make this a little bigger. This is going to be with SE2. So this is going to be my and then you're going to have this one in here, which would be SE1. Okay, very good. So those two join here. This one is going to join over here. And then we have the two minus that connect over here. But the first one that we have in here is with P9. No, with Q11 is 1 over C11 Q11. So that is going to be like this, 1 over C11, like this. And the other one is going to be R10 over I sub 9. So this is going to be R10 over I sub 9. Okay. So you see this comes from Q11. Do we already have Q11? We do. So that is this is going to join from here, right? Like that. And this the second one, it comes from P sub 9, which is the one that we have already evaluated right now. See? And can we do anything with the other ones? With P sub 9 on the first, we need to, because for DQ11 here, this was multiplied by 1 over I sub 9. So this one, too, is from here, but looks like it might interfere with the other. Let's just do this first, the one P12, and that one we don't have yet. But the P9 we do. So well, what can we do? Right there. Okay? So this connection we don't have because we don't have the other equation yet. So I'm just going to draw it here, making some space, and then we'll see how it goes for the last equation that I need to do, which is this TP12. So in here I'm just going to go and put the ingredients that we need. Perhaps I would do it here, right here. And I need this this block also. I need this one also. Put it over here. How many gains do we need? We have a source here. 1, 2, 3. 3 gains are necessary for this one. Make a little space so that things are efficient in here. We need 3 of these. 1. We need to create the model a little further down. Here. And then let's see, how do we this is the way to get things. There's 3 of those. It has 2 sources, right? It has 1, no, just 1. So we're gonna have to have this, and which one is it? SE3. We could have picked up from up there, but it doesn't matter. Okay, and so you have in here 1 plus for that, 1 plus for this, and 2 minuses. So 1 plus, 2 pluses and 2 minuses, right? So I'm going to go over here and create 2 pluses and 2 minuses, like that. And then make it a little bigger here. Of course, the SE3 would be one of the pluses in here. And then this comes from Q11, see? This comes from Q11. Let's see how we go about doing that. This is dp12dt, dp12dt, and the other one here is p12. Okay, so we need to, this one is Q11 of 1 over C11 here. So the 1 over C11 this one comes from Q11, which is this one. So we are going to have this. Yeah, that is, oh my goodness, this is going to be one of the pluses here, like that. And then the other one, it comes from Q14, which is this one, right there. And that goes to this one. And the other one comes from what? dp12, this one like this. And this will connect to the last one right here. Now it remains for us to fix this one in here, which is on the third equation that says 1 over I12, which is this one. It's in the Q14 dt, which is yeah, the Q14 dt. This is from P12. That is, of course, this one right here. So we have done that one. On this one, we still need to complete something in here. This, the term on the first equation comes with P12, right? Which is the one over here. See right there? And I think we have finished the whole block diagram of the state space equations of the differential equations. Now, what about the output equations? This E11 and the, this is 1 over C11 Q11. I think we have it, that signaling here. Right there is, this in fact is that signal right here. This here, this term is Q11 times this. So we could put directly that on a scope that you do control C and D. You just have to see where your variable is. Let's just flip this by control I in here, and I would, this is your, I would do, that is my E11. See, and what about this E14? It's 1 over Q14 over C14. So that's this one in here. We could just pick it up from here and create it with one gain. There's no problem. We could just duplicate. possibly is there, but just to be on the safe side, I'm gonna build it like that and create another scope in here. It will be like this. Q14, this is gonna be 1 over C14, yeah? So you have two methods basically. See if the signal is already there, and if it isn't, then just build it like this. And you have now the second output. And so your scopes in here are your state variables, but also they are the output variables. And we have finished transforming these equations on the left, the 4 differential equations, into block diagrams, as well as the 2 output equations.